Hi, it's time for another math easy solution. To discuss further into integration of rational functions by partial fractions, and this time go over example 8 of the example series. And in this example, we'll be trying to basically avoid having to even use partial fractions. So although basically this is the example we're going to go over. Integral of x squared plus 1 divided by x times x squared plus 3. Now, although we can solve this using partial fractions, for example, we could break this down into, partial fractions, a over x, where that's the factor for this one, and in the non-linear factor, we have a bx plus c, and this is the x squared plus 3. So although we could use this in this particular case, we can actually avoid having to use partial fractions at all by simply using substitution. For example, if we let u equals to, well, the denominator, x times by x squared plus 3. This one, if you expand this out, this is just x cubed plus 3x. Now the partial fraction, partial derivative, du is equal to, well, take derivative of this, 3x squared plus 3. Then there's a dx right here. Take the 3 out of there. We have a 3 x squared plus 1 dx, and as you can see, this is the numerator. So making the numerator by itself, we have an x squared plus 1 dx equals to, just divide this 3 out, du over 3. So move this over. So now we have all this. We could just plug this inside. So this becomes integral now of the numerator is gone. So 1 over 3 du over u. Now this is, because the denominator we let it equal to u. So this equals to basically ln absolute value of u plus a constant c. And you can see proof of this integral in my video link below on log, or natural log, or ln. So this equals to, once we substitute this u back in, 1 over 3, and u equals to, well, this, the denominator, but just make it expanded. So in this absolute value, this is going to be x cubed plus 3x right here plus c, and and this is our final answer right here. And as you can see, we avoided having to use partial fractions, but note that we can use logarithmic properties to show how we were basically able to skip a step in the integration by avoiding partial fractions. For example, in this one right here, we know that 1 over 3 ln, just put the factor out the x, we have an x times by x squared plus 3 right here. This right here. Now if we add, if we apply logarithmic properties, this is the same thing as adding it. So this is going to be 1 over 3 ln of, this is going to be right here, ln absolute value of x, because this is multiplication, so you add the logs. And this is going to be right here, 1 over 3 ln absolute value, but since this is an x squared plus 3, it is x squared plus 3. This is never positive, never negative, so we don't need the absolute value sign. So as you can see right here, we were able to break these apart, and also recall that the derivative of this ln x, so derivative d over dx of ln absolute value of x, is just equal to, well, 1 over x right here. So knowing this, and then similarly on this case as well, we're going to have a 1 over x squared plus 3 in the integral. Recall this, and these are basically the partial fractions here. So this is a partial fraction, and similarly d over dx, I'll just write this down, ln x squared plus 3. This just equals to 1 over x squared plus 3, and then times it by chain rule. That's going to be, well, 2x. Partial fraction, and I'll put an s right here. And this one is exactly where we have it right here, but again, you have to solve for the coefficients and then integrate. But so basically in this case, we were able to skip a step, and so just showing that sometimes it's easier and faster to use, to trying to avoid partial fractions if you can. So anyways, that's all for today. Hope you'll learn from this quick video, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another math easy solution.